Well, hey, everybody. Welcome, welcome, welcome. Mark Bare Naked Willie, let me move you around, my friend. All right. How much fun is this? It's another BS Friday. If you are just joining us, we have a great show. We have a special surprise guest, Michael Ingui, on with us. And if you are tuning in right now, please hit that like and share button because we want to grow offsite construction and building science because the two go hand in hand, fist in fist. And that's what we're doing here. So we can build more sustainable homes, we can build better homes, and we can build healthy homes. And that's what the conversation's all about. Mark, do you know that guy to the right of you?
I think that man deserves a new nickname.
Oh no, what is that? You always got to be careful, Michael.
Exactly.
How about we call him Michael the Accelerator, Mr. CNN Ingui?
That's fine. It's
Mr.
much nicer.
CNN.
I love that.
Were you on CNN?
Yeah, they did a great segment about 6 months ago, and it just started to get play a little bit recently, and it was fun. They got really into Passive House. The crew that was there was totally into it. It was fun.
Yeah. Michael, why don't you just take a moment and give our audience a little background on just 2 minutes from birth to now, everything. You get 2 minutes off.
Well, as a child. So Michael Ingui from Bax Ingui Architects. We're in New York City. We do a lot of passive houses, a lot of townhouses, historic masonry retrofits. We do houses out in Long Island as well and up in Westchester, but we do and what a lot of people have known as far as the passive houses that we're doing, we like to share a lot of information. So I'm also the founder of Passive House Accelerator. Zach Semke is the director of that and is really kicking butt on it. It's been a lot of fun, and I'm excited to be here.
Yeah, no, this is great. You're like a giant in the passive house world. So having you on is just super incredibly exciting for us. So I love it, Mark. Take it away, man.
So when we speak of giants in passive house, we also talk about, Dave, the people that that pass the torch, right? So Michael does that with his network and with his sons who also work with the accelerator. And without further ado, I think we should jump into it. Michael, can you kick off the show and tell us where we're going?
Yeah, well, I'm very happy to introduce Sean. He's become a good friend, and what I like most about Sean is it's rare to find someone so funny, easy to get along with, like totally approachable, who just happens to kick some serious butt. He's passionate about sustainable prefab houses. He graduated from the University of British Columbia with a degree in wood product processing. He's a certified passive house trade person. Also obtained a building construction technology associate certificate at BCIT while he was working at Viceroy Homes and Bosa Construction. He's now a product consultant with 475 High Performance Building Supply, which I'm sure everybody knows, for British Columbia and Alberta. And he's really, he's passionate. He's involved with instructing the passive house trade person courses. He talks about it a lot. He shares a lot of information. I've learned a lot from him, which is great. And he's been involved with BCIT in developing their high performance building lab. And he likes Legos.
Legos on top of it.
Which is always nice.
I can see him in the fish tank and he's smiling ear to ear down there. We're going to bring him in a second, but I don't know, Mark. I don't know if I can hang with this crowd. There's a whole lot of smarts here.
He also says good and fun, easy to get along with people. Dave, you and Michael are the same. It's important that we have people that carry that in our industry. It's a very giving network. It's a very sharing network. People don't think of construction or contractors in that way. But this is the voice of choice. This is the time to bring people into the industry and say, when I grow up, I'm going to be a project manager. I'm going to be an offsite professional. I'm going to be a building scientist.
So true.
Yep. Or I'm going to be a tech guy that helps run those machines that are creating all this high efficiency products that we're using. Right?
Amen.
Yeah, I love it. I love it. All right, so should we bring Sean in? He's on the boardwalk talking to somebody right now. He's on a boardwalk. Watch. This is no joke.
Hey
Hey,
everybody, how are we doing? Thanks, Mike, for that intro.
My
So
pleasure.
I'm in a bit of a special location today. I'm on Bowen Island, which is like a 30-minute ferry ride from Vancouver. And so you're right, I'm in Snug Cove, this beautiful marina. You can see the boats behind me. There's a guy mowing the lawn, so it's always nice to have that fun noise in the background. But a special thing about the best part is I've taken the classroom outside. I've got a couple of mock-ups we're going to talk about today. So great stuff, everybody. Thanks for having me.
you know, is it just me, or is he just already a natural on camera? You haven't done this before, have you, Sean?
Well, I've been on your show a couple of times. Well, good enough.
I love it.
I think Sean secretly has been following Geraldo Rivera's on location. And so let's start off with a headline. And Michael, would you stick around for the first Q&A with Sean?
Yeah, I will.
Okay, great.
Love it. Love it. All right, let's kick it off then. Hey, where do you want to start, Mark? There's a lot going on here. Do we want to bring somebody in, or what are we doing here?
No, let's go with the first banner, Dave. You've got a banner. Let's see if we can knock Sean off of his post.
Oh, you meant the one that matches his shirt?
There we go.
Love it.
Excellent.
Good.
Yeah, I
good,
love
good.
this, and it's timely because again, the Building Green came out with an article this week talking about insulation and looking at the whole embodied carbon, and it's a bit of a hot topic in buildings, and say maybe the last 6 months to a year. And I thought we'd just talk about it because as we're building high performance buildings, we just need to be aware about the materials we're constructing it with, because now that we're reducing the operating cost and the operating carbon of our buildings, these thick walls could end up being having a lot of embodied energy, and that's the energy to create these walls. And so looking at how to reduce it. And so yeah, we've got a couple of samples there. We've got a wood fiber insulation on that mock-up there, and we've got cellulose here, which are again organic materials. So yeah, those just kind of a bit
Sean,
of a that.
Sean, show us those again real quick, because I the camera flipped around on me.
Oh, sorry. So again, here we've got, these are, you know how I love prefab. So these are prefab from a company called Collective Carpentry in BC. Okay. And this here is a wood fiber insulation on the outside. So again, we've wrapped the building in a sweater. And then over here, the sweater is just cellulose. So hopefully you guys can see those okay. So here we've got a thick wall, again, about a 14-inch wall filled with again, recycled paper, and again, lovely sweater on the house.
Love it. Love it. Very cool. Very cool. So Mark, go ahead. Why don't you break that down for our audience so they understand what they're looking at?
So Dave, a quick plug, Benson Wood was on last week. Thank you for the hat. I know your son is wearing one now. The wall assembly Sean is covering is very similar to the one that Jay displayed last week. And so it's important that this becomes more mainstream, because what it's allowing for is a durable construction, right? Because he mentioned this is produced offsite. So there's precise measures done, but it's also reducing the energy use for the consumers. So we need that. We want that. We enjoy that in our lives and in our building.
Absolutely. Perfect. Perfect. Go ahead, Sean.
Yeah. So again, these thicker walls, we're talking about reducing the energy required to heat and cool them by, up to 90%. And again, it's because they're that thick. And so you look at details here, right, where you've got material that typically would be exposed, and you've got, minimizing thermal bridges. This one here where you've got that stud that is now being protected by that sweater, and making it where you're choosing materials that are allowing for drying. And that's a bit of a key. Sometimes we talk about walls like, oh, walls need to breathe. They don't need to breathe. The homes need to breathe. That's that HRV or ERV or fresh air machine, but they need to be able to dry.
I love it. I love it. Mark, I got a special guest for you guys. You want to see the special guest?
Yeah, let's do it.
You see that hat?
So
He's got his Bensonwood hat on.
We have
I think-
we have the next certified passive house tradesperson sitting right there, Mr. Colton. Hi.
Say hi.
Hi.
All right.
Hi, Colton.
Off you
Thanks
go,
for joining
buddy.
us.
Say hi.
Hey, how
All
are you?
right. He heard you show your hat, and he stood over here. He's like, I got it.
Hey, Michael, I think we need to get Colton a picture of your sons to put up on his wall to be inspired by.
We can make that happen. Yeah,
Yeah,
cheers.
Yeah, I'm curious. What do your sons do?
They're both really helpful with the accelerator. They're 16. They're twins.
Yeah. Oh,
They're
yeah,
both
twins.
at LaGuardia High School in New York City, but and one of them's certified passive house consultant. I took the test last year, and
16.
And he's quite into the mechanical and more technical end of it. I'm more interested in the design end, and he's more interested in learning how to make it happen.
I love it.
So it's been fun.
That's awesome. That's awesome. Well, we have a lot to talk about. I have twins as well. So,
Oh, cool.
all right, let's get back into it. What do you say? Enough chatter. Is it time to get a little BS going?
Yeah. Hey, Michael, can you talk with Sean about this assembly from an architect perspective?
Yeah, I mean, for me, it's made a big difference. To have this, as he puts it, the sweater around it, which is a great way to put it, it makes a big difference. It frees up the designer on the inside of the house, because although the walls are thicker, I don't have lots of stuff that I would need on the inside. I don't have ductwork that has to get all the way to that wall. I don't have radiators that would have been there. So although the wall's thicker, you save so much space and have so much flexibility. I mean, that combined with better windows, and it just makes for much easier, much better designs. So from a designer standpoint, it's just huge. Once you learn how to do it and see that the details are there, you just always want to do it that way. It's just much better.
Is there something you could point out while you're still with us here, Michael, on the display that Sean has in front of us?
I don't see his display. So
Sorry, I'm coming back to the mock-up here.
there you go. Give us a quick zoom of that. But
So I'll come this way so you can kind of see here insulation, stud, and then that service cavity where you'd be putting the electrical, plugs into your plumbing. And on this one, you got a 2x4 service cavity, but you can see the eye joist and then the cellulose, and then the plywood, which is sheathing, air barrier, and vapor control. So some good building science going on there.
Give us
two things there that are great. The one is a service cavity, which is so important, and then the other is just the idea of breaking those thermal bridges. The panel does such a good job of breaking the thermal bridges, because just not letting that cold in. And again, for anybody who's not familiar with a thermal bridge, so I'm holding my coffee cup, which does get hot, but if it was a thermos, the heat would never make it out. I wouldn't burn my hand. Thermal bridge. So it's to break those thermal bridges, especially in a cold climate, it's just so nice.
Yeah. What can you explain what a service panel is?
So the service cavity they're talking about, Dave, is inside of the vapor barrier in this case. And so when they're running their electric through there, you're not worried about the air passing through from one side to another.
Got it. So that's where they can run their electric, plumbing lines, anything like that stays in the conditioned space and it doesn't affect the thermal barrier.
Low voltage, sensors, you name it.
Yeah.
And if I could just jump in there regarding the air barrier, you just think of, typically we have our vapor control layer that's trying to be an air barrier, but we've got 200 plus switches, plugs that are poking through there that are holes in your air barrier. So now you literally, reduced all those, put them on the interior side of the air barrier, and now you're looking at an HRV inlet, outlet for a couple of hose bibs, a couple exterior lights and switches. So now you're talking like 8 places to focus on the air barrier strategy and not the 200 plus. So very simple, makes it easy.
And that brings down the cost of passive house significantly. So, that's, you've got these wall systems, but if you can put them up quickly and you've got your other trades that can deal with the service cavity, that makes it much faster. And that's what brings the cost back down to a palatable place.
Yeah. The MEP goes in faster and the routes are called out. The other thing, we all get technical in this, but when you look at that wall assembly, the part that makes a difference for the people, right, the most important part is the comfort. It is so quiet when you're inside of that space. Once you experience a passive house, both as someone working on it and someone staying in it, there's no going back.
Yeah.
And with that too, Mike's got a couple of great videos you can see, but, having, again, a high performance window, so triple pane window, that really reduces that sound. And so all of a sudden you've got a quiet home, and it's great to have that opportunity. So comfort, good indoor quality, of course, the energy efficiencies, but, we have fun with quiet and some of these other real benefits.
Yeah. So just if you could, Sean, real quick, explain the wall thicknesses on both of those again, so people understand that that's a 2x6 wall, 2x10 wall cavity, and just show us that service cavity as well one more time in the thickness, because we really want to simplify this, because we're merging two worlds together. We're merging building science with traditional offsite construction, and we're trying to educate. So we have some really, nerdy science people on here, but we also have guys like me that, I'm learning every day.
So this one's a good one because, again, you see your typical 2x6 construction. And all we've done now is added a 2x3 on the flat as a service cavity. And we've got, 60 mils of wood fiber insulation here, again, wrapped with an air barrier. The plywood is the air barrier and vapor controller, because that's taped, and we want the air barrier on the inside. So when we look at this traditional 2x6 framing wrapped with a sweater, in this case, it's a vapor open wood fiber insulation, could go from 40 mils up to 120, up to 106. So you could get it to be thick depending on what climate zone you're in, and then a 2x3 service cavity and inside. So that's this one, a little simpler. This one's a bit tricky because what we've done now is we've taken our 2x6 construction, reduced it to 2x4. So it's a regular wall, you framed up, you've got your plywood on, but now you actually are putting I-joists, connecting it to your sheathing. So the air barrier, vapor controls on the warm side of the wall, and you've got this big massive sweater. So this is a 9 3/8 I-joist screwed into it, and again, wrapped, and then has a cellulose. So vapor open, so you can dry both directions, airtight. These two are bomb proofs. And so this is where, builders are always looking for the lowest cost wall, the highest R value, the thinnest wall. And if you care about the planet, you're going to talk about the embodied carbon.
Love it. Love it. All right. Perfect. Let's keep rocking and rolling here. Mike, I really appreciate it. And I know we're going to have you on the show, and we're going to deep dive a little bit more into that world of knowledge that you have, but really appreciate you jumping on and doing this intro. Mark, you do an excellent job with keeping people in suspense.
Hey, Michael, you have a blessed day. We'll talk to you in a few days.
Yeah. Thanks, Michael.
Good, guys.
All right. Bye now.
Bye, Mike.
All right. Moving on. Let me move you around, Mark. Okay. Perfect. All right, let's move on. So we talked about embodied carbon. We talked about these cool wall panels on the boardwalk, making us all jealous because the rest of us are stuck inside. Let's talk about who the Building Science Corporation is.
Yeah, so again, I'm really lucky because we have some amazing mentors, and we have people like John Schraub and Dr. Joe Stiebrook that have been involved in building science for over 30 years. And, I haven't met them, but I've read their reports. I've seen other people that have worked with them and collaborated. And it's amazing because one of these days I'll give them a super high five saying, thank you for teaching me to be a nerd and, providing with a bit of work, because those guys are leaders in our industry to deal with the BS. And it's not BS, it's building science.
Huh. Interesting. Zach, do you agree with that?
I do, man. Great to be here. Yes, yeah. Building Science Corp is a tremendous resource to the building science community and the passive house world. Absolutely.
I love it. All right, everybody. Well, hey, welcome, Zach.
Thank you.
I appreciate you joining us today. Passive House Accelerator. Tell us a little bit about yourself, and then when you're done with that, before we get any more reactions from Sean, I think it's time to introduce some of our audience to the show.
Yeah, fantastic. So my name is Zach. I'm the director of the Passive House Accelerator. So I work very closely with Michael Ingui on that. And the Accelerator is an online open source platform for sharing information about Passive House design and construction. So, it's all about sharing lessons learned and mistakes made so that we can all progress and innovate quicker and more effectively. And it's a really exciting community to be part of, and it's all part of that spirit. I think that this show is about, and that Sean's work is about, and Michael's work is about. So it's an honor to be part of.
Yeah, it's an honor to have you for sure.
Thank you.
Go ahead, Mark. You
Dave,
say something.
Dave, you said you were going to bring in the audience so we could all say hello here. That's all I was doing.
Let's do it. Let's do it. Hey, we got good old Shane McNutt. What's happening, good old Shane McNutt from Ohio? Love it. Works with Nudo. Great guy. In fact, Mark, we're going to see Shane on the show on Product Spotlight coming up not too long. Which
Can't wait. Shane's a good friend. Welcome, Shane.
Good guy. All right, Anthony Goudet from New Jersey, building better and faster with offsite. Absolutely. Now, there's a guy that's taken a lot of time over the last few months to really understand offsite and building science. So kudos to Anthony. Andrew Sealy, howdy, y'all. I think howdy, why? Awesome. Love it, love it, love it. All right, he said, here's another one. Howdy, y'all. Joining from Texas Hill Country. This should be another fabulous show. We got George Ryman joining us from hot Phoenix, Arizona, 116. George, I don't know. What are you doing, man? Is it like the winners?
Dave, I think George needs some of those walls that Sean just showed us.
Yeah, you're not kidding, man. You need 30-inch walls, that kind of weather. That's hot. That's hot. Stay inside and drink plenty of water, George. That's my advice. All right, all the way from France, we got Henry Mickelberg, coolest surname ever. Love it, love it, love it. All right, moving on. Let's see what we got. Anthony made a comment, up to 90% reduction. Yes, sir. Do you think we could have got through this show without this guy? I don't know. He's asking, is it barriers like Passive Purple?
Could work.
I mean, it's kind of what's fun about this whole thing is, you guys all compete and work together in the same space, but at the same time, everybody has fun with it. I love it.
No, it's great. I mean, the Passive House community is just so collaborative, and we share and we learn, and it's just really exciting. And again, the work that Zach and Mike are doing, the Passive Accelerator, to again accelerate the movement, it's pretty awesome. And again, we're part of a bit of an open book when it comes to sharing our dirty laundry and learning from each other.
That's right. And there's exponential growth in Passive House construction around the world right now. So there's space for all of us to thrive. So I think that's part of the story as well. It's great.
Love it, love it, love it. All right. Hold on one second. I got to pull something up that I think would be in.
We have a surprise coming.
Is this the ICE, Mark?
Yeah.
This one?
Yeah.
Yes.
So start it up, and Sean, Zach is going to take us through the story of you and some of the things you do. So, Zach, you have the mic.
All right, fantastic. Well, the Icebox Challenge it was a public science experiment and science education effort that had two boxes, one built to code minimum and one built to Passive House construction. And then like a half a ton of ice is placed inside each box, and then it's all sealed up. And after a week, you look at how much ice is left in each box. And by the end of it, there's 4 times more ice left in the Passive House box compared to the code built box. So it's this really, and here you can see the code standard ice there, and then I think it'll show soon the big block of ice left in the Passive House box. So it's this great experiential way to show the energy impact of the thermal energy impact of Passive House construction. And these boxes were built by Sean as part of this large effort in Vancouver. He brought them down to Seattle. he stayed up all night with the firm that I was part of, NK Architects, to make this thing happen in time for the Seattle Design Festival. Then he brought them to Manhattan, and near like a block away from Times Square. He helped get them to Philadelphia and then to DC, where they were demonstrated. Hey, there we are, where we were demonstrated, where this experiment was shown like blocks away from the White House. So it's been this great kind of public education effort. And Sean is just, that's how I met Sean. I was just blown away by how passionate the guy is and just completely selfless about all this stuff. So it was very inspiring, and it's been, it's the Icebox Challenge is a tremendous success. So Sean, I have a couple questions for you. So one is,
fire away.
What makes you tick? what can you talk a little bit about what drove you to do that work? And then I guess the other one is one of the important, like the kind of the thing that seals the deal for people to understand the benefit, like how powerful Passive House can be in their own lives, is to actually experience being in one. So the Icebox Challenge kind of was experiential and showing, kind of demonstrating the science. But what do you think the next step is to help bring the experience, the comfort, the quiet, that experience of Passive House to the masses in a similar way that the Icebox Challenge did?
Yeah.
Gotcha. Okay, 3 great questions. I'm going to start with the third one first. I actually think about building like a tiny house on wheels that is built to high performance, where we take it on the road so that people can enter in, you close the door, and you get the comfort and the indoor air quality and that fresh air. And I got to experience it on a project in a cabin where, 40-year-old cabin. I'm sorry, I'm going to walk away from the lawnmower here. And so getting people to be in that quiet space, I think is one. So in China, they have a Passive House museum that really showcases it. And so we need to take the Icebox Challenge to kind of Icebox Challenge 2.0 with that kind of experiential about getting people to feel and touch the space. Then I'm going to come back to the second question about my passion. And I've kind of been on this 20-year journey from when I graduated university about wood products and being connected to sustainability and to the trees. And, I'll kind of give you a background. Here we are in BC with those lovely trees and these natural products, and we should be building with them. And so after I graduated, I was really interested. Do I go work in a sawmill or go work for the highest value-added product that we can make, which is a home? And luckily to go work at the time, which was the most automated factory in North America with all the Weinman lines and the Hundinger equipment that Bensonwood has. But again, it wasn't enough. They weren't sustainable enough. And so then my father and I decided to start up a company and try to push the buildings. And we tried to become a spec passive home builder. And then I ended up being involved with 475. But this product right here, again, this wood fiber, it'd be great to have that manufactured locally so we can drive down the cost and make it affordable for everyone to have, because it's such a great product. So that answers the second one. The first one, what makes me tick? It's when I go to a job site and the builder hasn't even thought about his air barrier strategy. I can walk up and I see this beautifully framed house and there's nothing going to stop the leaks. And I go to them and say, what's your air barrier strategy? And, oh yeah, the poly or the Tyvek's going to do it. And then we have this discussion of how it's not connected. That makes me tick. I really could, swear a little bit, because I get so frustrated when builders can provide a beautiful home, amazing kitchen and bathroom, again, quartz countertop, stainless steel appliances, but they forgot about the assembly, the envelope that is, again, not durable, not sustainable, and not healthy. And that's going to affect the homeowner. And that really just drives me nuts.
Love it. Love it. Great explanation. Let's hit a couple more comments so we don't get too far behind, and then we'll keep jumping through. Does that sound good to you?
Keep going.
All right. We got Joe Butler. Love me some Western Canadian expertise and contributions. Thank you for joining, Joe. All right. Here's my book writer, my friend, Henry Mickelberg. Mark, where'd you go, Mark? Sorry, guys. I'll read this one out loud. In France, we have multi-couche, aka multi-layer insulation. It's typically 25 layers of foil insulation, etc. Think NASA insulation. It's really cheap. It just staples to wood and apparently provides the same level of as insulation as 150 millimeter rock wool, 6 inches. I used in my own passive house in conjunction with rock wall and extruded insulation to remarkable effect. The point being, it's less than an inch thick, meaning the wall isn't 14 inches thick. I have yet to see it in these. I'm sure there's more following up somewhere.
If I could just dive on that quickly again, vacuum insulated panels are a great product. The problem is though, is again, if you order a 2-foot by 4-foot panel from Panasonic, if you poke a hole in it, that R value of, I think R60 per inch is now down to R10. However, you know, there are applications where you could use it and embrace it and not lose that R value, especially on decks. So you'll see it more common as we move it along, and high performance builders are looking for some niche products in certain areas. That's a good product to deal with it. But again, it's about affordability, and those products are still a little bit further ahead compared to our normal construction.
That's a good point, Sean. And the vacuum insulated panels, the VIPs, Dave, they're very well set up for an offsite panelized modular facility, so that you know, you get these panels in the set sizes and you can install them and put on your raceways and protections. A lot more difficult to do in the field. Certainly, there's a lot more moving parts in the field and a lot more unknowns in terms of exact sizes as compared to the joys of offsite.
Perfect. All right, let's get through a few more comments and then we'll hop back into the conversation. We got Cashflow Chris, blowing my mind. So much cool info here. Thanks for sharing. Well, thanks for joining us, Cashflow Chris. Really appreciate the feedback. I'm not sure about this next one, Sean, between you and Adam, but I got to put it up there. He said you guys are lovers, not fighters.
We are.
Hey, what can I say? Why not?
Well, they always say,
moving on.
You got to get 3 quotes. So again, there's lots of opportunities to get quotes from people to understand the different systems, and then, you know, for the client to understand the product. A lot of times we don't ask why, we just tell me the price and then we compare price, but it's what's happening and comparing apples to apples, and a lot of times we don't do that. So
speaking of 3 quotes, Sean, you can watch Building Science Fridays on 3 different applications: Facebook, YouTube, and LinkedIn. So thank you all for joining. Hit that like button.
I love it. Thanks, Mark. Sometimes I lose track following all these things. There's comments galore, but you're absolutely right. 3 locations, Mark. Love it. And people are joining us from all over. You know, it's grown, and that's been a great thing. And it only grows because everybody out there is liking and sharing the content. And I hope we're bringing you guys value every week.
Yeah, Sean is in British Columbia, Michael in New York, Zach in Washington, you're in Connecticut, right? And I'm in somewhere.
You're in different states all the time. All right, we're gonna get to 2 real quick, and then we're gonna get back to bringing everybody some more BS. George Ryman asks, what other fibrous materials can be used in your product? Are there any supply chain concerns regarding locality or availability?
yeah, so the wood fiber, again, there's 5 or 6 different manufacturers in Europe. We prefer Gutex because the manufacturing process is 40% less energy compared to the other products. So that's kind of why we're a pro about it. It comes in a rigid board. It could actually also be in a bat form and also blown in. So those are kind of the 3 product mixes that Gutex comes in. But we typically see it in bat because, again, we want the sweater. We want that exterior insulation to stop the thermal bridges.
The other point to that, George, and Zach asked Sean the question, and the location that's best suited for this is in the mill areas of Canada, because you have byproducts of many different lumber sequencing that happens, and so it would be a great area. If anyone is listening that wants a large R&D facility and manufacturing facility in Canada to produce these panels, you need to talk to Sean. This is one of his passions and missions, and we need it in North America.
Yeah, 100%. All right, we're going to one more, and then I keep saying that, but they just keep getting longer and longer. Joe Butler's joining the book tour. Love it. Sean, we now have a fully robotic factory in the interior of British Columbia, located just outside of Kamloops. I think I said that right. Just installed a Randec zero labor system in this factory, along with some really cool cool lot to mine data while manufacturing open and closed wall systems.
Joe, I know about it. I've talked to Jason, and I can't wait to see it. I saw the foundation being poured in February as I drove by. Can't wait to see it. It's going to be fantastic.
Yeah, and Joe, hey, we're getting ready to do a road tour, and as soon as Canada opens up, we'll be heading that way and live streaming on location. So if you have some information on what you guys are doing, send it my way. Mark and I love road trips.
I think Sean and Dave and Zach, that's up in the Northwest Corridor there. You all can have lunch together, take us on a live video so the rest of us can enjoy this.
Absolutely.
Virtual laptops.
All right. So let's hop into it. Sean, moving forward, talk to us about this Gutex wood fiber board. You've mentioned it earlier about houses not needing to breathe. They need, the walls insulation, they need to be dry. So with that said, what is so different about Gutex wood fiber board than if I was using a rock wool or anything else for inside my walls?
Yeah. So again, it first comes back to the raw material that it's started with. So we're talking about using fibers from the wood fiber or wood industry. So in southern Germany, they got a bunch of sawmills, bunch of mass timber, and all of that excess fiber that's getting planed off their sawmills or kind of off the waste stream. What do you do with it? You could burn it, you could give it away to hog fuel or whatever. But about 80 years ago, these Germans in southern Germany decided to make a board product out of it. And in this particular manufacturing, instead of doing, and this is where we're going to really dive into some real BS, is they use a dry process in the drying. So using steam versus using water. And so the manufacturing is 40% less energy requirement compared to the other wood products that are out there. And so, like as Mark said, we now need to start some local manufacturing here in North America to drive down the cost of the shipping, and so we can make it competitive to other insulation products. And so again, it's organic because again, it's from wood, and so we talk about that renewable product. And again, I'm a big fan of it. That's all I can say.
The embodied energy to produce products is often an unknown equation. So the more we bring this up as normal vocabulary in our projects, it's not just bidding for the least expensive materials. It's being inclusive of how those materials are sourced, where they're sourced, how they're made, how they're installed, and the effects they have on our logistics process and the life cycle of our homes.
Yeah. So on top of that, Mark, just to come back again, we talked about, that drying ability again is understanding the materials we're putting in and how they affect the building science of the walls. Some insulation products become a vapor barrier versus being a vapor retarder. And then again, the importance now is these thicker walls, the embodied carbon is a big conversation. And we've got a couple of conferences in September, Zero Carbon and Reset, to learn more about this. And so very much a hot topic in the holistical building industry, and lots of good conversation, lots of great leaders that are popping in. Chris Magwood, Anthony Pack, like we're lucky to have again good leaders to connect with.
Yeah, for sure. So we were talking about this, so I was looking for some of your photos and the videos because you mentioned about shipping and packing. So I just happened to have these. Man, you got big, dude. You've been working out, huh?
My body double, that's Bob from All Elements. He's a builder in West Kelowna, wearing our t-shirt that says, build like the future depends on it. So, you guys need a name on a t-shirt. We already have it on a t-shirt. So
yeah. So explain, is this how the installation comes shipped?
Yeah. So this particular product comes in a 2 foot by 4 foot, almost 8 foot high pallet. We've got a boom lift that's taking it off this particular load. And so, you got a 40-foot container that crossed the ocean. And again, that really you're shipping air because that's just wood fiber with a little bit of glue, the multi-therm, which can act as a sheeting, not a sheeting product, but a water-resistant barrier. So yeah.
Yeah, I don't know if this will play. I'll give it another. Well, I have another one. I can get to it another way, but I was going to show you guys taking these off the truck. So let's talk about this, if I could, for a minute, Mark. I'm curious to really hop into what is the R value when you put all this stuff together. What are we looking at? And I know you're going to give it to me in Celsius, so I went ahead and did a little bit of calculation. I didn't do the math for people, but we'll put up the, as you said, for your friendly American friends, they can figure out the Fahrenheit. So I got that ready to go.
Good. Okay. Well, so I mean, on a typical home, you know, that comfort level that we all like is somewhere between 19 and 21 degrees Celsius, right? So we're kind of around that, you know, 70, right, degree plus or minus a few Fahrenheits, and that's where, you know, the body and humans like. And so these extra layers of insulation we're putting on means that we don't need to be burning fossil fuels or other heat sources to generate the heat or cooling we need, because the sweater is holding in that temperature, stopping, you know, thermal bridging and other material losses. Again, and it's kind of funny, we talk about, we put you know, slippers now on our foundations, we're putting a sweater on our walls, and we're putting toques on our roof. So hopefully you guys know what a toque is.
Well, why don't you explain to us, because I have no idea what a toque is.
A toque is just a Canadian phrase for, you know, a warm fuzzy hat.
Well, you know,
a little Canadian knowledge today, guys.
Sean, I think Mark and I need some of those toques.
Well, again, we've got some Gootecks too, so I'll try to find you one.
I've heard of loonies. I've heard of toonies. I've not heard of that.
Yeah,
Dave, you asked about the R value of these walls. So one of the missions that that Zach takes on is to introduce architects and the construction industry to someone that models the building, right? So you have these CPHCs and PHI and FIAS have different ways of explaining what these folks do, but what they do is they calculate for your project what the R value, what the U value of the wall assembly needs to be. So it's all planned. It's all planned in advance. And when Sean showed us those different walls, he was showing us different thicknesses. He was also showing us different ways in which the vapor and the air is controlled. So each application depends on what you're trying to achieve on each project. There's not a silver bullet. There's a plethora of information to help your decision and to plan it.
Hey, Mark, I'm just going to interrupt you because my helicopter is here to take me away now. I don't think I can see that. So I'm going to say goodbye because my phone is about to die, but my helicopter arrived up. So on that 3.6 R value of Gootecks, 3.2, 3.5 for cellulose, and I'm out. I'm going to get to the helicopter. Bye, everybody.
What's the matter with you, man?
Hey. So, Mark, you were talking about the tools that passive house designers have, and it's really so whether it's you're working with FIAS or PHI, the tools are essentially a way to optimize design. And so you're like, this is my goal, and what is the most cost-effective and easy to build way to get to that goal? And then the added layer that we're looking at more now is we know is what material goes into the toque and the sweater. You know, that's what the embodied carbon is. And Architecture 2030 is saying that from now to 2050, we're going to be building new construction, essentially the equivalent of New York City every like 30 or 40 days. So the carbon intensity of the materials we're using is absolutely critical to our future and the future of our, the hope of keeping a stable climate. Yeah. So if we can figure out ways for more and more of those materials to actually be sequestering carbon rather than creating a bunch of carbon emissions in their production, then we can make a lot of headway. So we're operational carbon, which is the carbon emitted in heating and cooling and operating a building. Operational carbon can be tackled really cost effectively with Passive House, and now we're bringing in that same kind of sensibility on the embodied carbon side as well. So it's really vital work, but lots of smart people doing, making big progress on it.
Zach, that's a great point. So when you're talking about that many buildings being built, right, the equivalency of New York, you said?
That's right.
And Dave brings this all the time. We have so much we need to build, and we need to do it right, and we need to do it fast. The other point that we can't skip over, and this is essential with the embodied carbon, is existing buildings.
Absolutely.
So,
yeah.
20, 25 years ago, when green was a big topic, you had developers come in and they said, we need to take down all these buildings and build all green buildings. And there was folks in our network that we would literally freak out, because we're not telling you to take down buildings. We're telling you to save the buildings you have. And Michael Ingwe does a great job of this in New York. And add to them, so you could preserve that energy that's already in the structure and give it another 200 years. So we want to make it clear, it's not just the need in the offsite community to be incorporating building science, but it's in our existing building stock to not tear down those structures and to embrace the embodied energy of those structures. And then I wanted to jump into that, but I want to ask a question back to you, Zach. The modeling that they use, we often refer to it as WOOFY, right? So in the building science world, not everyone is aware of that. So can you?
Well, I mean, essentially the modeling is looking at how moisture and heat operate in building assemblies. And so WOOFY allows you at a fairly granular level to really understand how the building is working as a system. So we're no longer talking about rules of thumb and kind of, this is the way we used to do it, but we're drilling down to looking at, hey, if I've got this multifamily building, that is inherently efficient because of its the kind of boxiness of it, maybe, or the fact that the relationship between the surface area and the volume of it is so advantageous. That's the case with larger buildings. Maybe I don't need to do triple pane windows, and I can still perform at a Passive House level. Is it possible for me to bring that down to double pane windows? And what implications does it have in terms of what I spend on insulation? So you can play with those different parameters and dial in the best solution that ensures comfort and durability and health and energy efficiency.
Zach, that was so well said, because in my early years at Passive House, we were doing only residential projects, and then you stated these larger buildings. So in the smaller buildings, the volume is not there, and so these triple pane windows are necessary in most of the projects. But when you get to these large commercial buildings, the surface area is small in comparison to the volume.
That's
so they
right.
are able to achieve these with the double pane windows.
It depends on, it depends on the climate, of course, because you still the comfort issue is still really important to look at. So, but in Seattle, there are some where I'm based. We have a mild climate and a relatively mild climate, and so there are projects that can succeed with double pane windows. But again, it's a case by case basis. But it doesn't. The beauty of these tools is that you don't have to go and get your PhD to dial in the right answer. It's like it's there, it's available off the shelf, these tools, and there are lots of designers out there that you can hire, cost at an economical level to help you narrow it down to the best solution. And the cool thing is that the passive house consultant and the architect can sit next to one another and be playing with different choices, and that can free up the architect to make to do new things, but also translate that into buildable details, and details so it can be built offsite as well.
So we don't need a PhD to build a comfortable building. We need a PH accelerator.
That's right. Well done. Thank you, Mark.
I love it. I love it. All right, listen, we got a few more comments. We're not getting through everything today. Mark, we're almost at 55 minutes.
That's because we had a helicopter.
We did. And, it's kind of funny. Henry said I wouldn't get in that helicopter.
I agree. I'm in my van, phone's charged, so I can continue on. And I can't agree more with Zach too. And what's nice about these designers, like there's a local builder, Steve Kemp, and he talks about when we start a project, we have 1.4 million decisions to make to get down to about 80 different products. And so, that's a large, a lot of things to figure out quickly. And so builders are trying to figure out what wall assembly can work, how do they learn the air barrier system and strategies to make it effective, and then just repeat it, and then ideally convert from on-site to off-site, and then scale it up even more.
Love it. Love it. All right, a couple more comments, and we're going to wrap it up, fellas. Mark, was there anything of super importance that you wanted to make sure we covered today?
It's super important that we have this conversation with our network and we invite people. So we're not silos, right? It's super important to inspire the next generation. Sean is doing that impactfully with the message that Zach brought forward of the Icebox Challenge, and the fact that there could be trainings done. If you're looking to do a project, these manufacturers, they will openly teach you about the materials and how to achieve these healthy, comfortable buildings, right? Because no one wants to live in an uncomfortable, unhealthy building. You can't afford to.
Right. Love it. Love it. All right. A few more comments, guys, and we're going to wrap it up here. Henry, just make sure you go and check that out, Sean. He wasn't sure he's on the same page with you on that, but he sent a link. Let's check it out. I mean, that's what this is all about, right, guys? It's about sharing knowledge, sharing information, and having good, strong conversations, which is the only way we're going to change how we do anything. So love it, love it, love it. Yep. We got Osama Alabi joining us from Bavaria. What's happening, man?
Nice.
I'm glad to see you. It's been a while, Osama. I hope all is well. Look forward to catching up with you in the future.
Send us some of those pretzels.
Oh, yeah. Yeah, we love the pretzels. All right, Tom Reddy. So refreshing to hear the innovative and open to collaboration approach. If Synergy Steel can assist in any way, please let me know. Always a pleasure. Jennifer in the background, bringing design architects into the process sooner is a major win in offsite construction and net zero passive house. Build better than code. Yep. And I think we'll open up the next series, Mark, where we're going to get into the step code and all those things. I know we didn't get to it today, but that was part of the dialogue we were going to have. But I didn't know Sean had a freaking helicopter, man. Wow. Love it. Love it. Love it. All right. That's what we have, Mark. What do you think?
I think I don't want to wrap up the show. Sean, can you wrap up the show, because we got to less than 25% of what we planned on getting to.
Yeah.
And that list was already reduced from what we've talked about over the last several weeks. So, Sean, you have the floor. Tell the industry what they need to hear. And I thank everyone, Dave, Zach, Michael, for the work you do in your networks, and the outreach that's done with Accelerator is beautiful. So bless your hearts.
Yeah, thank you, Michael and Zach and Sean, for being on the show. Sean, you're going to have the final word, man. We're going to let you take us out. Let's make it not long-winded, not short-winded, just a little winded.
If I could say anything to the builders. It's it. If builders, if you're listening to this, I would hopefully you'll take away is figure out your air barrier strategy, because as a builder, that's the best thing you can do to improve the quality of the homes. The engineers, the architects, the energy modelers can work on the sweater details and the mechanical equipment, but please think about, consider the air barrier strategy you have and work towards the below 1 air change, or passive house of 0.6. But start to develop your systems before the codes change. In the next 5 to 10 years, you could be ahead of your competitors and provide your clients with, again, up to 90% less energy homes, and they're going to be comfortable and healthy. And you can do that with the knowledge and with what we can offer. So connect with anybody. Again, always, my phone's always open, and send me an email. And I love, like as you can tell, I love this. I could talk about it all day long, but we got to wrap up the show. So air barrier strategies, take it and go.
Hey, hang on. We got 70 seconds, Sean. Please tell us what 475 means.
So you'll love this. So in the passive house, we have a couple of constraints. And one of them is the heating demand, which is, I'll do the German method, which is a metric. So 15 kilowatts per meter square per year. But when you convert that into imperial, because 475 is out of Brooklyn, New York, you convert that into imperial, it ends up being 4.75 BTU per feet squared per year. There you go, 475. Here to help.
All right, everybody. How about a big smile and a thumbs up? And we will see you next Friday on BS Friday. Thanks, everyone.